This is a Nakamichi 1000 cassette deck, and this is a laptop which has the Audiomatica Clio measurement system installed. So let's start with the Clio. Clio is an electroacoustic measurement system. You can measure transfer functions, you can measure small parameters of a loudspeaker. You can do inductance, capacitance measurements. It's a multi-purpose PC-based measurement equipment. This one is an old one. In fact, that's why I'm keeping it, because it has the Wow-Flutter measurement available. What's the Wow-Flutter measurement? So the cassette decks or tape decks or even turntables, anything that is rotating it and that is not 100% cross-controlled generate fluctuation of the recorded content. Like if you have a pure sine tone, the sine tone may be faster or slower depending on how the mechanism is turning or how the band being pinched. Many different ways it can go wrong. So Clio can show us how bad the deviation is by putting the frequency on the y-axis and time in the x-axis, and we can observe if the frequency is stable. We should only see one line. That is what the current PCM recorders do. So if you have a PCM recorder from Tascam, Marantz, Sony, whatever, you are going to have one single line, meaning that there is no deviation of frequency as a function of time. But if you are playing music through that cassette deck, tape deck or turntable, you will see that there will be some variations to it. And currently it is plus minus 100 Hz because we didn't start using this equipment. So how are we going to measure this thing? It's quite simple because this is a 3-head cassette deck. We can record and play back at the same time. What Clio will do, Clio will generate a tone that is specified either with the NAB standard or IEC standard, and the right head will put it on the tape, and as the tape rolls over the playback head will pick it up and it will send it back to Clio, and Clio will compare the output, which is a fixed sinusoidal tone, and it will give us the delta of what is being picked up as compared to the reference signal, and it will start plotting it like we in fact see it on an oscilloscope screen. We have a monitor and source option. I'm going to leave it at the source for the first time because I want to see if Clio by itself doing a good job. So I'm going to say pause so that the line in circuit is available. I'm going to set the frequency first to 3 kHz. And I'm going to start generating that tone. As you see, we are registering it. We can check it from the headphones that this sound is coming out. That's good. We don't need to monitor that thing. But now with Nakamichi we are monitoring the source, meaning that whatever comes to the input of this device goes directly out. So when we start the measurement, Clio will give us a straight line, and if you look at the scale, it is not from 100 to minus 100 anymore. It is minus 0.2 to plus 0.2, meaning that there is no lower scale that Clio campoded, it's just a straight line. That is exactly what we have anticipated from a digital system. And now we are going to start recording, and we are going to go to tape, and we put the output to Clio. Now Clio is settling down. I just want to show that this has nothing to do with the gain. Of course, if your cassette deck is so crappy that the gain will change some voltage levels, and that will affect the motor speed, okay, but as far as this measurement setup is concerned, it shouldn't make any difference. So what we are looking at here is, since this is a 3 kHz tone, Clio is registering what it is picking up on the input. So we are almost there, but not quite. And how not quite it is displayed here. It is -20 to +20. So plus minus 40 Hertz peak to peak. And you can see the NAB and linear and weighted. Here they are registering around 0.3 and IEC 0.6, because when we go and change this to 3120, we just in fact align it to another standard. Of course the Clio has to resettle to that frequency because this is doing average, but the figures do not change much. So by looking at the shape of the Nakamichi 1000, you may think that, oh, maybe this is not a prime example of how the Nakamichi 1000s are behaving. Yet again, aside from the faceplate of this thing, behind it, it's a very clean machine. It has new sets of belts, all the voltage and everything meets to the factory requirements. So yeah, it looks like why we moved away from this technology. You can hear the swing very clearly, even with the tape deck, which has new belts, new capstan and pinch roller. And there's nothing you can do about it. You can, such a rigid construction, you can even move the tape from side to side, up and down. It won't change anything. This is what it is. So yeah, let's stop playing with Nakamichi and move to another cassette deck of that period. And here we are sitting in front of a CT-F1000 from Pioneer. This cassette deck has the new belts, new pinch rollers, and all the voltages have been checked, and they are according to the factory specs. We are going to start with the source, and we are going to check if Clio is going to do a great job. We can observe it from the screen. We are generating 3 kilohertz tone, and Clio is reporting 3 kilohertz, and we are going to wait all to see all the metrics are converging to 0, and like before, the scale has been adjusted to minus 0.2 to plus 0.2 hertz, and once we put the pause, start recording and lift the pause, we are still monitoring this source, and I'm going to switch to tape, and Clio will show us what the tape is doing. As you can see, now the scale has been changed to minus 40 to plus 40, and we are having 3 kilohertz plus minus 40 hertz swing on a cassette deck that compiles, conforms with the factory specified voltages and has new bells and pinch rollers. So I think there's a good reason why we left the tape and this technology completely behind us. And if you want to hear an advice between Nakamichi or Pioneer or any other cassette deck, I think my advice will be to stay away from all of them. Yeah. With that bombshell, it's time to end. Goodbye.